The AI boom has created enormous expectations, but the reality inside most enterprises looks very different. Studies show that only 5% of enterprises' AI pilot projects actually reach full production, while the rest stall in experimentation or pilot purgatory. My name is Paul Nashawaty, and I'm the practice lead and principal analyst for the AppDev practice. And I'm joined by Ketan. How are you doing today, Ketan?
Yeah, I'm doing very well. It's a great day here in Seattle. So
Excellent. Good to hear. Why don't you tell the audience a little bit about yourself and a little about Union AI?
yeah, as you said, my name's Ketan. I'm the CEO and co-founder of Union. At Union, our goal is to essentially make you go from 0 to 60 with your AI products. We do it through making it really easy for you to write and express your ideas, and then take them to production. We manage the infrastructure, the durability of the orchestration, and the scale.
That's great. I mean, it's awesome because, I mean, of course, in this day and age, we have a lot of activities that are coming up around AI. A lot of organizations need help. Despite this massive investment, excitement around AI is most organizations are really struggling to turn AI ambitions into operational reality. What we're seeing is research is showing that as many as 78% of enterprise AI projects fail delivery meaningful business value. Like, they just don't add that value that they promised, and only a small fraction ever make it from pilot to full production. And this issue isn't just that models don't work. It's organizations are discovering how hard it is to build AI projects. It isn't about building the models. It's about operating them at reliability in scale. That in closing the gap between experimentation and production is really where AI initiatives stall. So, Ketan, I love Seattle. I love the area. It's a great place. It's great to have a good day. But let's jump right in here and talk about this, because this is an important topic. The AI boom has really created expectations for innovation, and organizations are really struggling with operational kind of getting it running here. So what's driving this gap between AI ambition and execution?
That's a great question. And, I'll start off by saying one specific thing. The tools that we have built for, solving our traditional software problems are just not built for AI. We're just doing it wrong. And the reason is the traditional software tools were built for software that had a deterministic core. And the traditional way is you erect the infrastructure, then you connect the pieces, and you kind of deploy, and you scale out, and you take 6-month projects. This methodology does not work for AI. The challenge is the core that I talked about was deterministic is non-deterministic. It's an AI model that's making the decisions for you. And so when such a thing is happening, there's no one clear guaranteed solution. You want to try and experiment very quickly. So what you want is a system that allows you to quickly iterate and try different ideas rapidly, without getting stuck in the 7,800 hours, according to your report, that people are spending in just maintaining their infrastructure. That should be the second thought. Like, the first idea should be, how do I try this idea very quickly? And then once it works, take it to production. And this is where we've been trying to help people.
Yeah, and let's not minimize. You didn't, when you introduced yourself, I don't know if you kind of highlighted the fact that you're the co-author of Flight as well, right? So we want to make sure that that's kind of put out there. And when we talk about these tools, Flight is a way to help accelerate these initiatives, right? And when we did this economic validation with you, the report really did highlight some surprising disconnects between engineering and managers and AI teams. This is kind of funny because we had a lot of dialogue around this internally, around like what we were seeing in the reports, and this, like, when we look at this, why do you see this disconnect emerging, and how does it really impact and affect organizations to really move more quickly? Because I think communication is key here, but also talking about the disconnect is really a big factor here.
It is. You're absolutely right. I think many times we've seen that the managers and their teams are disconnected, and they're out of touch with what's happening. And this actually kills AI productivity. One of the reasons for this is, like, you and I, like, we see demos. And when we see demos, we're like, oh, that works. That's great. How can I get it done? And then when you go to your teams, the teams are usually they look at the demo and they have to now productionize it, and they have to now wrangle data, get security concerns, reliability, manage various compute, and the compute itself is very complicated. There's various types of GPUs, TPUs, and so on, and you have to manage this extreme complexity. And this is not easy. And when you couple that with the tool sprawl and the tools that were traditionally built for software without the focus on iterating rapidly, it just exacerbates the problem. And this is not directly understood by the managers because they're looking at that end outcome from a demo perspective, and they don't know what all is going in the back.
Yeah, absolutely. Actually, in our syndicated research in 2025, outside of the economic validation report, we found that 75% of the audience indicate that they use 6 to 15 different tools in order to do things. So the tool sprawl, to your point, is there. But one of the most pervasive problems we were seeing in that economic validation was highlighted in the report is reliability, right? We were seeing that. That was a big factor. We reran some questions. We cut the data a certain way. We're doing data cuts to make sure we understood it. But let me ask you the question though. Do you see stability and governance matter as much as innovation, or do you see this as a shift in the market? Like, do you see things kind of moving in a way that stability and governance are important when we start looking at what I would call the citizen developer doing development? Governance, compliance, and regulation need to be put in place. What are your thoughts around this?
That's a very, really, really good question and observation, I would say. What is the challenge of, building products? The number one challenge when you are in production is reliability. There's a reliability crisis today, right? You cannot rely on that agent that you build or your AI product to consistently deliver the same outcomes. And reliability is measured in different ways, right? It's reliability of the outcomes, reliability of the infrastructure, reliability of the software. And as we bring on more and more developers onto the platform, if we focus and force every single developer to think about this reliability, this is an extremely high expectation from all of the even citizen developers, as you said. Like, for example, you start using an Anthropic model, and on your demo examples it works. And then the moment you scale, you get throttled, or you don't have enough GPUs and you don't get a response. You start using some data, and you were working on your limited data set, used about a few megabytes or a gigabyte of data, and that was easy to work with. You go into production and it needs hundreds of gigabytes of data. It doesn't scale, it doesn't run, right? So most of our customers have actually told this to us. That's why they come to us, is they rely on us as the reliability layer to their software. So we make it very easy for them to build that software, and we bring in the reliability. And as we progress more towards agentic and other pieces of software, self-healing software is becoming a key piece. And how do you self-heal in cases of adverse failures, like, as I said, throttles or infrastructure issues? You need a software layer that kind of adapts to it. And that's where we kind of have been seeing a lot of our users get a lot of value from.
Yeah, I think that is absolutely a forward-looking statement. I think it makes a lot of sense. One of the things that I hear quite often when I talk to CIOs is the two main barriers that people run into, or these organizations run into, is complexity and skill gap issues, right? Yeah. And when they're doing this, they're looking at their heritage environments, right? They're looking at what are they looking at to kind of move forward? How do they modernize? How do they get to today's goals with yesterday's code, right? And something else that was really interesting from the report was when you look at these teams, they're using older software tools to build AI, right? And part of that is because a lot of their heritage environments are still built in a heritage way. So but why not? Why don't say orchestrators? Why don't they work well when developing AI? Why is that a problem? Because you have this heritage, you're going to bridge the gap between old and new. Why are they say these things like orchestrators not working well?
They were designed from a different perspective. Let's take an example, and I'm going to say this out loud. We are in a software 3.0, a new era of software, and most of the software tools that we have were built from the previous world. Think about microservices and erecting pieces of infrastructure, then connecting them. That's like the modus operandi for most of the software tools. You start with an AI product, for example, and the first thing you do is you try to come up with like, okay, how do I solve this problem? And the immediate obvious answer is usually not one answer. It's more than one. So increasing the number of iterations you can do to try and arrive at a potential solution is how you can effectively deliver more or get more ROI from your products. And to do that, if you take a traditional tool, any of the big orchestration solutions out there, the first thing they tell you is, yeah, write the code, sure. And then now erect the infrastructure, connect the pieces, deploy it, get it through, and then push it in production. But I don't even know if that's going to work. That's like probably you're saying like I have to bet my horses on something that I don't believe in. That's not the right way to do it. You're going to take 6 months to achieve a production demo, which may not work. And I'll give you an example. Like, do you think Anthropic doesn't have 3 new models in testing right at this moment after Claude 4.6? Absolutely. Which one's going to win? Even they don't know. They are testing them. They're finding out, and one of them will win. And so the real value, if everybody has to take one thing out, is to find ways of effectively iterating more faster, right? Iterating faster and cut that time down so that you can try more ideas so that when you find the right ones, you can take them to production effectively.
All right, so let's pivot a little bit, but let's stay on that same thread and talk about finding ideas and knowing about like what to do next. One of the big things that came out of the report was, we did a qualitative and quantitative research, right? We talked to your customers love you. They work with you. They have nothing but good things to say. But that's all well and good. That's anecdotal information, and everybody can make those statements. But I want to talk about the 9.8 times ROI number that we calculated in this research, because that, in my mind, shows that you can innovate. You can, to your previous point, you can try things faster and then fast fail on the things that are not working and move forward on the things that are. But how is Union really pulling that off? And with that kind of return for users? Because that, in my mind, is a significant way to experiment, try, move forward, and keep going.
It's honestly, like when I first saw the number, I knew it was valuable, but our customers told us we get about 9.8x ROI by using your product. And we started diving deep, and we kind of, always when you start with a product, you have a hunch of why things are working, and this validates that data. The reason why I believe that people are able to do so much more is something that you just said in your previous question too. There are some old tools. One of the older tools that is very prevalent today in the AI world is like a programming language called Python. Started in 1992, right? It was not even built for this world, but it's very, very relevant today. But now you can get lots of developers who know how to use Python. But it's very inefficient when you deploy it at scale. It's also extremely hard to get the resiliency and everything correct. But you can find talent very, very easily who knows Python. So what we do is we make it possible to keep using that one, that thing that Python, but we make it resilient, scalable, reliable, and manage the compute completely underneath so that the compute is available just in time to run your things, and it goes away when you're done. So this has not only made your talent extremely, extremely efficient, it's also using the compute extremely efficiently. And this combined together really blows past the ROI expectations for most customers. And then, of course, the iteration time. All our customers told us that they've seen a 96% reduction in iteration velocity or increase in iteration velocity, which is dramatic. And that has, and these together couple gives you high ROI.
Yeah, that is amazing, because I mean that in itself, I know that the mileage may vary based on clients' accounts, but like overall, even if you aggregate the number of accounts that you're working with, it was amazing to see those numbers come to life. And I do think that you're right. I think that there's the ability to kind of move fast, try things quickly. iterate on tool sets that are in place, like you were saying. We also see in our syndicated research that 67% of organizations are hiring generalists over specialists. So it also, and I'm not going to put words in your mouth, but it also reduces complexity to some extent, because you can actually try things in a way that it makes it easier to use. But I also want to touch on reality. I'm sorry, not just reality, but I want to touch on that too, but reliability, right? When we look at reliability, what does Union, do really to help teams to help with workflow failures? Because that's inevitably going to happen as we start build out these, show these examples.
Yeah. Very good question. I think there is a reliability crisis. I said this, right? And that is why things don't reach production. And I said there's a perceived set of reliability problems, but there's also underlying reliability problems in the infrastructure layer. We are an infrastructure company, and we help you with managing the complexity and the reliability problems at the infrastructure layer. A forward-looking example is a very interesting way to think about this as well. So if you think about, we've talked a lot about this current world, we're talking a lot about agents and so on, or we take about, we deal a lot with ML companies that build machine learning models or train large data sets and so on. In all of those cases, the challenge is you dynamically need to provision infrastructure to solve that problem in that moment. So you need to handle failures that happen at the network layer, at the storage layer, at the compute layer, and even at the cloud layer. And we take care of all of that, and we completely abstract it, give you a simple way to write code in Python, which is what all your talent knows. And it scales. And it's not only your talent. Nowadays, even all your coding tools know really, really well how to write Python. And we take care of the rest underneath. And that's how most of our customers are getting huge value from the system.
Yeah, that's really important. I mean, I'll just use a specific use case that I see in our research. We see that 24% of organizations want to release code on an hourly basis, yet only 8% are able to do so, right? So when I think about that, I think about the value that you're providing to organizations to reduce that iteration speed. Can you touch on that piece too? Because I think that is a big factor here when we think about the SDLC and releasing applications, but also making sure that that businesses are basically hitting their KPIs.
Yeah, let's remind ourselves. Like, I think AI products, I know AI products have a non-deterministic core. What that means is the problem you want to solve, but you actually don't know the right solution off the bat. So the solution is really not picking one fight and going with it, right? Because it's probably not going to end up with a good result. What you want to do is try different ideas. It's experimentation. And how do you improve? Like, let's take an example of a clinical research company, right? And you're trying to get a new drug out. If I go to a company and says like, yeah, I know this exact compound and we know we can get it out and it'll be a huge billion-dollar success, that's a dream. It doesn't happen. They usually have a problem. Like, I want to solve cancer, and I want to take like 500 different ideas and break it down into 200 and cut it down into 10, and then finally go into clinical trial with 3, and then finally arrive at the one result, right? That is the modus operandi that you have to take for every AI product. Every AI product is research-based, and you need to understand. And this, I think, also leads to that there is a huge gap between technical managers understanding that it is research-based, not traditional software, and the teams having to actually do that work. And so if you can reduce the time to iterate and increase the number of iterations concurrently and dynamically, you can basically put more arrows against that one target, and which increases your chances of hitting the target.
Yeah, and success, absolutely. So, Ketan, this has been great having you on. It's a lot for the audience to think about here. It's a lot for people to consider. Closing thoughts. What do you think? Where can the audience go to learn more? I mean, this is a lot to think about. So where can they go to learn more?
Yeah, I'm probably given them to think about a lot more, because it's not completely known and well understood. And people who are building really high scale production AI products are working with us, and they do this, and that's how they are achieving their results. So if you are interested in learning more and getting and being part of a community, we have an open source project called flight.org. Join the community, ping me, talk to people, members, and we are happy to engage. Or if you want to do a private chat, our teams are here. Ping us, and we would love to get on a call, understand your problems, and see how we can help you.
Absolutely, and also any of the data that we talked about on this episode can be found in the economic validation report that we built. So that's another area to find out some information as well. Don't believe us, look at the customer data; they speak for themselves. So. But Ketan, really great having you on. Thank you for being my guest today. And big thank you to all of you who've tuned in. We do appreciate you being part of the AppDevANGLE community. But for now, that wraps up this episode. But we'll be back next Wednesday with another conversation diving into the tools, trends, and talents shaping the future of application development. So whether you're deploying at the edge, building with AI, or modernizing your cloud stack, we've got you covered. Be sure to follow us on social if you have any thoughts, questions, or just want to connect. Until next time, stay curious and stay building. That's